This is an example video for the topic, using the rational zeros theorem to find all zeros of a polynomial, rational zeros. Let's say we're given this polynomial. We are given that it has at least one rational zero and asked to find all zeros of the function. To do this, we'll first need to identify a sub 0 and a sub n. A sub n is the leading coefficient, so a sub n in this case would be 6. A sub 0 is the constant term, which in this case is 7. Using the rational zeros theorem, we know that the only possibilities for rational zeros of g of x are numbers of the form p over q, where p is a factor of a sub 0 and q is a factor of a sub n. So any rational zero of g of x must have the form p over q, with p being a factor of 7 in our case, and q being a factor of 6. So our next step is to find the factors of 6 and 7. Our factors of 6 are plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Our factors of 7 are plus minus 1 and plus minus 7. So the possible values for p over q are listed below. Plus minus 1 over 1, plus minus 7 over 1, plus minus 1 half, plus minus 7 halves, plus minus 1 third, plus minus 7 thirds, plus minus 1 sixth, and plus minus 7 sixths. Next we can check these numbers until we find a zero of g of x. We find 7 as a 0 because when we substitute it into the equation, the result will be 0. And we can use the knowledge to find the remaining zeros of g of x. Based on the factor theorem, there must exist a polynomial q of x that satisfies the following equation. The x minus 7 comes from our knowledge that 7 is a 0 of g of x. We can divide 6x cubed minus 41x squared minus 8x plus 7 by x minus 7 to solve for q of x. If you would like to brush up on your division skills, I would suggest reviewing the topic Polynomial Long Division. The result of the division here is q of x equals 6x squared plus x minus 1. We can find the remaining zeros by using the polynomial we found to be q of x. We can factor this polynomial into the factors 2x plus 1 and 3x minus 1. If you need a refresher on factoring, I would recommend reviewing the topic Factoring Polynomials. From here, we can solve for x by setting each factor equal to 0 in this way. 2x plus 1 equals 0, and 3x minus 1 equals 0. We already have our first rational zero of 7 from our first factor telling us that x equals 7. We can solve each of the other linear equations in this way. For the first one, we'll subtract 1 from both sides, resulting in 2x equals negative 1. Next, we will divide each side by 2, resulting in x equals negative 1 half. The second can be solved in a similar way as well. Add 1 to each side, 3x equals 1, then divide each side by 3, giving us x equals 1 third. This gives us our results of negative 1 half and 1 third as the remaining rational zeros of the function. So our final answer would be 7, negative 1 half, and 1 third.